On January 7th, questions surrounding the 3i Atlas project continued to draw attention as a clear contradiction emerged between US government agencies. While NASA has stated that 3i Atlas is simply a natural object of cometary origin, the agency has not provided detailed analyses to explain the unusual physical features and orbital anomalies that have been observed. In contrast to NASA's restrained messaging, the CIA invoked a Glomar response refusing to confirm or deny the existence of any records related to 3i Atlas in response to a Freedom of Information Act request submitted by the Black Vault. According to Professor Avi Loeb, this approach may reflect the government's quiet assessment of a potential black swan scenario, a low-probability event with potentially high consequences, while simultaneously attempting to limit the risk of social unrest and financial market disruption in the face of unresolved uncertainties. In addition, some sources have extended the discussion by speculating that 3i Atlas could be linked to a form of extraterrestrial technology being monitored through advanced military reconnaissance systems, although no verified evidence currently supports this possibility. If our current understanding of Atlas is based on incomplete or even unreliable data, then what exactly is being concealed? That is the question we will begin to explore next. As observations of 3i Atlas accumulated, attention gradually shifted from the object itself to the response of institutions observing it. NASA issued brief classifications describing 3i Atlas as a natural interstellar comet. The statements about 3i Atlas were technically accurate yet notably restrained. They contained conclusions without extended discussion. In previous cases, anomalous behavior in celestial objects often prompted detailed briefings. NASA publications typically include uncertainty ranges, competing interpretations, and future research plans. With 3i Atlas, much of this explanatory structure appeared absent. The agency acknowledged the data, but the narrative around 3i Atlas remained minimal. This absence did not imply deception, but it did introduce a gap. 3i Atlas exhibited measured accelerations and directional features that were unusual enough to merit discussion. NASA did not publicly refute these observations regarding 3i Atlas. Instead, NASA largely moved forward as if the anomalies required no elaboration. Scientists outside institutional channels noticed this silence. Independent researchers referenced publicly available datasets related to 3i Atlas. These researchers posed questions that remained unanswered by official releases. 3i Atlas thus became surrounded not by controversy, but by missing context. Silence within scientific institutions can emerge for many reasons. Data review cycles take time and provisional findings are often withheld. In the case of 3i Atlas, however, the lack of commentary persisted even as observation windows narrowed. The object continued its passage while explanations remained sparse. This informational gap created a subtle shift in perception. The focus moved from what was known about 3i Atlas to what was not being said. No formal declaration of uncertainty accompanied the confident labeling of 3i Atlas as ordinary. The contrast between classification and explanation became difficult to ignore. NASA did not deny that unusual features existed within the data for 3i Atlas. NASA also did not affirm that these features required new models. Instead, the institution allowed the discussion around 3i Atlas to quietly dissipate. This strategy neither confirmed nor dismissed the significance of the observations. For many observers, the absence of explanation carried emotional weight. Humans are attuned to gaps in narrative, especially when expectation meets silence. 3. Atlas became a focal point not because of dramatic claims, but because of unanswered questions. The quiet surrounding 3i Atlas invited speculation precisely by avoiding it. As 3i Atlas moved farther along its trajectory, the opportunity for direct study diminished. The silence remained steady and unbroken. Whether intentional or procedural, the informational gap around 3i Atlas altered the tone of inquiry. The story of 3i Atlas was no longer shaped solely by data, but by the space between statements. When public curiosity around 3i Atlas intersected with formal information, requests the response from intelligence institutions introduced a new layer of complexity that extended beyond astronomy and into governance. A Freedom of Information Act request directed at the CIA sought clarification regarding assessments, reports, or communications related to 3i Atlas, and the response did not provide documents, but instead invoked what is known as a Glomar reply. This form of response, which neither confirms nor denies the existence of records, is legally narrow and historically specific, and it has been reserved for situations where acknowledgement itself is considered sensitive. In ordinary circumstances involving natural celestial objects, agencies typically respond by stating that no relevant intelligence records exist, thereby closing the inquiry without ambiguity. In the case of 3E at last, the decision to employ a Glomar response subtly altered the informational landscape because it introduced uncertainty where a simple denial could have sufficed. The Glomar mechanism does not assert significance, yet it signals that the subject intersects with protected methods, capabilities or priorities. 3E at last therefore became associated not only with scientific anomalies, but also with procedural caution. Historically, Glomar responses emerged during the Cold War to conceal covert operations rather than to obscure benign phenomena, and that historical context inevitably shaped interpretation. While the response itself offered no evidence regarding the nature of 3E at last, it suggested that some aspect of the inquiry fell within classified domains. Analysts emphasize that classification does not imply extraterrestrial origin, nor does it confirm threat assessment. Instead, classification often reflects the desire to protect observation methods, analytic frameworks, or surveillance assets. If 3I at last had been observed using non-public instruments or defense-linked sensors, acknowledgement of records could reveal more about human capabilities than about the object itself. 3I, Atlas thus occupied an ambiguous position between scientific curiosity and institutional discretion. The Glomar response neither validated speculation nor extinguished it, but it prevented closure by design. This procedural ambiguity functioned as an indirect confirmation that the question itself intersected with sensitive evaluation processes. From an emotional perspective, ambiguity carries weight even when it carries no facts. Observers did not receive answers about 3I at last, but they received confirmation that the question had been taken seriously enough to be constrained. That distinction altered perception without altering evidence. As 3 Atlas continued its trajectory, the Glomar response remained static, offering no evolution or clarification. The absence of follow-up reinforced the sense that 3 Atlas had crossed an invisible boundary between open science and restricted analysis. Whether the boundary existed to protect data methods or institutional prudence, it reshaped the narrative environment surrounding 3 Atlas. In this space between confirmation and denial, attention shifted away from certainty and toward interpretation. The Glomar response did not state what 3I Atlas was, but it quietly indicated that some questions are managed differently when uncertainty intersects with consequence. Within analytical circles, 3I Atlas gradually became associated with a category of risk that exists at the margins of probability rather than at the center of expectation. This category, often described as a black swan scenario, refers not to events that are likely, but to events whose consequences are so significant that even minimal probabilities demand attention. 3 at last entered this conceptual space not because of any confirmed threat, but because uncertainty surrounding 3 at last intersected with unusually high informational asymmetry. In risk analysis, low probability does not equate to low importance when potential impact is systemic. 3 at last was therefore not framed as dangerous, but as insufficiently understood within conventional timelines. Institutions responsible for planetary defense and strategic forecasting routinely explore unlikely scenarios as part of standard precautionary practice. Within this framework, 3 Atlas could be examined without presuming hostility or intent. The analogy of the Trojan horse emerged in discussions as a metaphor rather than an accusation. In the original story, the danger did not arise from the object itself, but from assumptions made about the object's nature. 3 Atlas, when viewed through this lens, symbolized the possibility that misclassification could delay recognition rather than provoke alarm. The metaphor did not claim that 3 Atlas concealed anything, but it questioned how certainty is constructed under incomplete information. Strategic analysis often considers whether an external system could appear benign while performing an unobserved function. Applied cautiously, this reasoning does not assert that 3 Atlas performs such a function, but it allows analysts to test institutional readiness. The value of the exercise lies not in proving intent but in revealing blind spots within detection and response frameworks. 3 Atlas thus became useful as a stress test for assumptions rather than as an object of fear. In this context, monitoring does not imply expectation of failure, but recognition of asymmetry between observation capability and unknown variables. 3 Atlas moved through observational windows that were brief when compared to the scale of strategic evaluation. Once 3 Atlas passed beyond optimal range, retrospective analysis would replace direct measurement. This temporal constraint amplified the incentive to consider worst-case models alongside conventional ones. Emotional responses to black swan scenarios often arise from misunderstanding the purpose of such analysis. The goal is not to predict catastrophe, but to ensure resilience if assumptions collapse. 3. Atlas served as a reminder that rare events define system limits more clearly than routine ones. Preparedness in this sense becomes an expression of humility rather than fear. As 3 Atlas continued along a calculated path, the Trojan horse analogy remained hypothetical and unresolved. No evidence emerged to elevate the scenario beyond intellectual modelling. Yet the presence of the question itself altered how 3 Atlas was discussed within certain analytical domains. The object became less about what 3 Atlas was, and more about how uncertainty is managed when the cost of error is asymmetrical. As discussions around 3 Atlas entered risk assessment frameworks, emphasis shifted away from origin questions and towards structured evaluation. Risk analysis rarely seeks certainty, and instead relies on graded scales that balance probability against potential impact. In this context, 3 Atlas was not assigned a conclusion, but positioned along a spectrum of uncertainty. Such placement allowed institutions to respond proportionally without escalating public concern. Risk scales function as internal tools rather than public declarations. They exist to guide monitoring intensity, resource allocation, and analytical priority. When applied to 3 Atlas, these scales did not indicate imminent danger, but they did justify continued observation. The distinction between observation and alarm remains central to policy design. Historical precedent shows that premature disclosure of speculative risk can produce unintended consequences. Financial markets, social stability, and public trust are sensitive to ambiguous signals. For this reason, information regarding 3 Atlas may have been deliberately framed in neutral language. The objective was not concealment, but containment of uncertainty. 3 Atlas therefore became part of a broader conversation about communication thresholds. At what point does incomplete data become necessary for public awareness? And at what point does disclosure create anxiety disproportionate to evidence? These questions are procedural rather than conspiratorial in nature. Institutions tasked with managing uncertainty often prioritize calm continuity. By limiting commentary on 3 Atlas agencies may have aimed to prevent speculative amplification. Silence in this case functioned as a stabilizing measure rather than an admission of concern. The absence of dramatic statements reduced the likelihood of reactive interpretation. 3 Atlas continued to be assessed quietly as it moved beyond optimal observation range. Internal frameworks likely updated risk classifications incrementally rather than decisively. This gradual approach reflects a philosophy that favors adaptability over final judgment. In such systems, uncertainty is not eliminated, but managed. From an emotional perspective, the policy of restraint can feel unsatisfying. Humans seek narrative closure, especially when confronted with the unknown. Yet stability often depends on allowing questions to remain open without urgency. 3 Atlas thus became an example of how modern institutions attempt to balance curiosity, caution, and collective calm. The most persistent physical anomaly associated with 3 Atlas emerged not from distant inference, but from direct imaging where a structure appeared that challenged long-established expectations of comet behavior. Astronomers observing 3 Atlas identified a prominent anti-tail extending in a direction oriented toward the Sun, and this orientation immediately conflicted with classical models of solar-wind interaction. In standard cometary physics, dust and ion tails are shaped by radiation pressure and solar wind, and these forces reliably push material away from the Sun. 3 Atlas, however, displayed a structure that appeared to resist this dominant force while maintaining coherence over time. As observations continued, the anti-tail of 3 Atlas was measured to extend hundreds of thousands of kilometers, and in some frames the structure approached distances nearing 1 million kilometers. Such scale alone did not violate physics, but the directionality of the anti-tail in 3 Atlas introduced tension within explanatory frameworks. Researchers initially explored projection effects, where viewing geometry can create the illusion of reversed orientation. These models were applied to 3 Atlas, yet the anti-tail persisted across multiple angles and observation windows. When projection effects failed to fully account for the phenomenon, attention turned toward particle size distribution. Large dust grains can behave differently under solar radiation, and under certain conditions they can momentarily appear to drift sunward. Simulations incorporating extreme grain sizes were tested against the data from 3I Atlas, but the results required assumptions that stretched beyond typical cometary compositions. 3I Atlas again occupied a narrow region between plausibility and strain. Another line of inquiry examined the timing of the antitail relative to perihelion. For most comets, unusual tail structures are transient and appear near peak solar heating. 3I Atlas demonstrated anti-tail persistence both before and after perihelion, which complicated thermal explanations. This temporal symmetry suggested that 3I Atlas was not responding passively to solar proximity alone. The discussion surrounding 3I Atlas remained cautious, as no single observation implied violation of physical law. Instead, the anti-tail behavior of 3I Atlas suggested either a rare combination of natural parameters or an incomplete understanding of interstellar object dynamics. Researchers emphasize that physics does not fail abruptly, but rather reveals gaps through edge cases. 3I Atlas increasingly resembled such an edge case. Instrumental bias was rigorously evaluated and largely dismissed. Independent observatories recorded comparable anti-tail structures associated with 3I Atlas, and calibration checks did not reveal systematic error. The convergence of data sources strengthened confidence that the anomaly resided in the object rather than the instruments. 3I Atlas therefore remained a physical puzzle rather than a technical artifact. The challenge posed by 3I Atlas was subtle rather than dramatic, and this subtlety demanded patience rather than alarm. No acceleration beyond theoretical limits was observed, and no energy imbalance was detected. Yet the orientation and persistence of the antitail in 3I Atlas resisted comfortable categorization. The phenomenon lingered as an unresolved detail rather than a disruptive revelation. In scientific practice, unresolved details often carry disproportionate importance. They signal where models require refinement rather than rejection. 3I Atlas, through its anti-tail, quietly indicated that interstellar objects may interact with stellar environments in ways not fully represented in existing datasets. This possibility reframed 3I Atlas as an opportunity for learning rather than a problem demanding resolution. As 3I Atlas continued its trajectory, the anti-tail gradually diminished in visibility and the observational window began to close. The data collected during this period became finite, and future analysis would rely on archived measurements rather than new observation. 3I Atlas left behind a record that did not provide answers, but it preserved a question within the structure of physics itself. That question would persist long after 3I Atlas moved beyond the reach of direct scrutiny. As analysts reviewed the institutional response to interstellar objects, attention settled on a discrepancy that was procedural rather than sensational, because 3I Atlas appeared to receive a level of attention not previously applied to similar visitors. Earlier interstellar objects such as Oumuamua and Borisov passed through observational frameworks without triggering intelligence-related information controls, yet 3I Atlas intersected with review mechanisms associated with national security. This distinction did not suggest threat, but it raised a question about classification criteria rather than object behavior. From an institutional perspective, intelligence agencies do not evaluate celestial objects based on scientific curiosity alone. 3I Atlas entered analytic pathways that prioritize uncertainty, combined with consequence even when probability remains low. The involvement of the CIA in matters related to 3I Atlas therefore reflected risk governance rather than extraterrestrial inference. In this context, 3I Atlas functioned as a variable within scenario modeling, rather than as an anomaly demanding explanation. One explanation considered by policy analysts focused on timing and data resolution. 3I Atlas arrived during a period of expanded global surveillance capability, where sensor networks integrate civilian and defense-linked observation platforms. If 3I Atlas was detected or tracked using assets whose capabilities are classified, then any acknowledgement of records would implicitly reveal those capabilities. 3I Atlas thus became indirectly connected to intelligence sensitivity through observation method rather than object nature. Another factor involved trajectory and approach geometry. 3I Atlas followed a path that intersected regions monitored for strategic early warning, which differ from zones emphasized during prior interstellar encounters. This spatial overlap meant that 3I Atlas passed through systems designed for detection, rather than discovery. Once such systems are involved, procedural constraints often follow automatically. 3 at last also arrived amid heightened institutional awareness of low-probability systemic risk. Strategic doctrine increasingly emphasizes preparedness for unexpected vectors, rather than reliance on historical precedent. Within this framework, 3 at last represented a case study rather than a conclusion. The object allowed analysts to test response protocols without asserting intent or origin. Importantly, no public evidence suggested that 3 at last triggered emergency measures or defensive postures. The attention surrounding 3 at last remained administrative and analytical rather than operational. This distinction supports the interpretation that 3 at last was evaluated as a scenario rather than as a signal. Intelligence interest in this sense reflected institutional learning rather than alarm. From an emotional standpoint, selective attention can feel disproportionate when context is missing. 3 at last became a focal point not because of what was revealed, but because of what was procedurally restricted. The absence of similar responses to previous objects amplified this perception. Yet within structured risk assessment, variation often reflects evolving frameworks rather than unique threat. As 3 at last moved beyond optimal observation range, the institutional processes surrounding 3 at last did not escalate. No additional disclosures followed and no narrative closure was provided. 3 at last remained classified not as dangerous but as unresolved, within specific procedural boundaries. In that unresolved state, 3 at last illustrated how attention can arise from context as much as from content. As the discussion around institutional attention continued, one hypothesis emerged that focused less on 3 at last itself and more on how 3 at last was observed. Modern space surveillance relies on a layered network of instruments, and some of the most capable sensors are operated for defense rather than for civilian science. 3 at last may have entered observational domains that are not routinely disclosed, where data collection is optimized for resolution persistence and strategic awareness. Military satellites are designed to track objects with precision that exceeds most public astronomical systems. These platforms can monitor small, fast-moving targets across wide regions of space while maintaining continuity over long periods. If 3 at last was detected or followed using such systems, then the resulting data would be inseparable from the capabilities of those instruments. 3 at last would therefore become indirectly classified not because of intrinsic properties, but because of the tools involved in observation. This distinction is important within intelligence frameworks, where protecting methods often outweighs sharing findings. Releasing detailed imagery or telemetry related to 3 at last could expose sensor resolution tracking algorithms or orbital coverage. Such exposure would carry strategic cost unrelated to astronomy. 3 at last thus represents a case where transparency about an object could compromise unrelated national assets. Historical precedent supports this interpretation. Objects detected by classified systems are often reintroduced into public datasets through degraded or delayed information. 3 at last may have been observed first through channels not intended for scientific discovery. Once that occurs, procedural limitations tend to persist regardless of subsequent civilian observation. 3 at last also move through regions of space that overlap with monitoring zones designed for early warning and situational awareness. These zones are continuously scanned for artificial objects, debris, and unexpected trajectories. When 3 at last passed through such regions, the object may have triggered automated tracking protocols. 3 at last would then be logged within systems whose outputs are not easily disentangled. From this perspective, intelligence interest does not imply suspicion of intent. 3 at last does not need to be artificial or threatening to warrant classified observation. The mere fact that 3 at last intersected sensitive surveillance architecture could be sufficient. Classification in this sense reflects infrastructure rather than inference. The hypothesis of military satellite observation also explains the asymmetry between public imagery and institutional restraint. Civilian telescopes provided limited resolution views of 3 at last, while higher fidelity data may remain inaccessible. 3 at last could therefore be better understood internally than externally, without any obligation to share conclusions. This imbalance creates the appearance of silence even when analysis exists. Emotionally, the idea of hidden observation can feel unsettling. Humans associate secrecy with threat even when secrecy serves technical protection. 3 at last became a focal point for this tension as curiosity encountered procedural opacity. The discomfort arose not from evidence, but from the awareness that some perspectives remain unseen. As 3 Atlas continued along its outbound trajectory, any classified observation window would gradually close. Archived data related to 3 Atlas would persist within restricted systems, while public science moved on. The hypothesis of military surveillance does not resolve the mystery of 3I Atlas, but it reframes the silence surrounding 3I Atlas as structural rather than intentional. In this framing, the unknown remains not because answers are withheld, but because the pathways to those answers are not shared. When attention turned toward the search for technological signatures, observations of 3 Atlas entered a different analytical framework governed by probability rather than expectation. SETI initiatives directed radio telescopes toward 3 Atlas during limited observation windows, and these efforts were designed to detect narrow-band transmissions commonly associated with artificial signals. The absence of detected signals during these sessions was reported accurately, yet the interpretation of that silence required careful context. 3 Atlas was observed by radio instruments for periods measured in hours rather than days or weeks. Such timeframes are constrained by telescope availability, competing priorities, and orbital geometry. From a statistical standpoint, a short observation window samples only a fraction of possible transmission behavior. 3. I at last therefore cannot be described as silent, but rather as unobserved outside those intervals. Efficient communication systems do not typically broadcast continuously. Energy conservation favours brief targeted transmissions rather than persistent signals. If 3 Atlas were associated with a technological system, its signalling behaviour might involve low-duty cycles or highly directional beams. In that scenario, the probability of coincidence between transmission and observation becomes extremely small. 3 Atlas also traverse space at interstellar velocities, which further complicates detection. Relative motion introduces Doppler shifts that can move signals outside monitored frequency bands. Although SETI algorithms account for such shifts, they rely on assumptions about signal structure. 3 Atlas could theoretically employ formats not optimized for human detection frameworks. Another limitation arises from directional uncertainty. A signal transmitted from 3 Atlas may not be intended for Earth-based receivers. Communication systems designed for long-distance interstellar exchange would prioritize specific vectors rather than omnidirectional broadcasting. 3 Atlas, therefore, could emit signals that simply never intersect terrestrial listening arrays. It is also important to consider temporal strategy. A probe or autonomous system crossing a stellar system might transmit data intermittently, perhaps only at specific milestones. 3 Atlas could have transmitted before, after, or entirely outside the observation windows conducted by SETI. Silence during a 5-hour interval does not meaningfully constrain such possibilities. From a methodological perspective, SETI results are binary only within narrow parameters. Detection confirms presence, but non-detection rarely confirms absence. 3 Atlas thus remains unconstrained rather than excluded by radio silence. This distinction is essential for maintaining analytical discipline. Emotionally, the public often interprets silence as resolution. In scientific practice, silence frequently reflects insufficient sampling. 3 Atlas became an example of how limited data can appear definitive when stripped of context. The absence of detected signals felt conclusive only because the conditions of listening were not widely understood. As 3 Atlas moved beyond effective listening range, opportunities for extended monitoring diminished. Future analysis of 3 Atlas would rely on archived data rather than real-time observation. The narrowness of the SETI window thus became part of the broader pattern surrounding 3 Atlas. Not a failure of detection, but a reminder that observation itself is constrained by time alignment and assumption. As inquiry expanded beyond radio silence, researchers began to consider whether the search itself had been constrained by inherited assumptions about communication. 3 Atlas was initially evaluated through frameworks shaped by human technological history, where radio waves dominated long-distance signaling. That historical bias shaped expectations more than evidence, and it limited the interpretive space surrounding 3 Atlas. When silence appeared, it reflected the limits of listening rather than the absence of expression. Advanced communication systems, particularly those optimized for efficiency across vast distances, would not necessarily rely on omnidirectional radio emissions. 3 Atlas could in theory employ tightly collimated laser pulses that reduce energy loss and minimize detectability. Laser communication allows data to be transmitted in brief intense bursts that are difficult to intercept without precise alignment. If 3 Atlas utilized such a method, Earth-based receivers would need to be positioned within a narrow transmission cone. Microwave signaling represents another possibility that blends properties of radio and optical communication. Such systems can offer directional control while remaining resilient to interstellar interference. 3 at last may have passed through observational blind spots where microwave emissions were not actively monitored. In that case, absence of detection would reflect instrumentation choice rather than signal absence. Time compression further complicates detection strategies. Efficient interstellar communication may favour sparse transmission schedules, sending information only at key trajectory points. 3 Atlas could have transmitted data briefly during approach or departure outside the temporal focus of monitoring programs. Without continuous observation, such events would pass unnoticed. Another consideration involves non-electromagnetic signalling entirely. Some speculative frameworks explore the use of neutrinos, gravitational modulation, or quantum-correlated systems as communication carriers. These ideas remain largely theoretical, yet they highlight how limited current detection paradigms remain. 3 IATLAST, if associated with technology, would not be constrained by human engineering traditions. Directionality also matters deeply in communication design. Signals intended for a distant origin point would not be broadcast toward incidental observers. 3 Atlas may have oriented any transmissions along trajectories unrelated to Earth's position. In that context, listening without knowing where to listen becomes a probabilistic exercise. From a scientific standpoint, expanding the communication hypothesis does not assert that 3 Atlas is artificial. Instead, it clarifies that non-detection under narrow assumptions cannot meaningfully resolve uncertainty. 3 Atlas remains undefined not because evidence is hidden, but because the search space is vast. Understanding that space requires humility rather than conclusion. Emotionally alternative communication hypotheses often provoke discomfort because they dissolve closure. The idea that 3 Atlas could express itself in undetectable ways unsettles expectations of confirmation or denial. Yet uncertainty is a natural companion to exploration at the edge of knowledge. 3 Atlas becomes a reminder that silence may be meaningful only when the right questions have been asked. As 3 Atlas continued beyond practical reach, the opportunity to test unconventional detection strategies narrowed. The moment passed without resolution, leaving behind theoretical scaffolding rather than answers. 3 Atlas thus occupies a space defined by possibility rather than proof. In that space, communication remains an open concept rather than a failed experiment. The hypothesis of an ancient signal associated with 3 Atlas introduced a temporal dimension that exceeded ordinary astronomical interpretation. If a transmission linked to 3 Atlas were dated to approximately 4.7 billion years ago, then the implication would extend far beyond the lifespan of human civilization. Such a timestamp would place the origin of the signal before Earth fully formed, when the solar system itself was still emerging from a protoplanetary disk. 3 Atlas would therefore not merely be passing through space but traversing epochs. Time in astrophysics is usually treated as a backdrop rather than an active variable. 3 Atlas disrupted that comfort by suggesting intentional timing rather than random arrival. A signal sent billions of years ago would require extraordinary foresight or non-biological persistence. 3 Atlas thus became associated with planning on a cosmic scale rather than chance alignment. Natural explanations were considered first because science always begins there. Signal dating relies on indirect inference, and error margins can be substantial at deep time scales. 3 Atlas could be associated with artifacts of measurement rather than intention. Yet even conservative interpretations left the timeline uncomfortably ancient. If the signal hypothesis were entertained, then 3 Atlas would represent a messenger rather than an observer. Sending an object toward a future civilization requires predicting stellar evolution, orbital mechanics, and the emergence of technological awareness. 3 Atlas would have needed to arrive not simply anywhere, but at a moment when detection was possible. This coordination suggests deliberation rather than coincidence. 3 Atlas also raises the question of motive rather than mechanism. A message sent so early could not be conversational, because no reply would be expected within meaningful time. Instead, such a signal would function as a marker, a record, or a warning placed within the flow of cosmic history. 3 Atlas would then serve as a time capsule rather than a probe. The emotional weight of this possibility rests in scale rather than fear. Human history becomes brief when measured against billions of years. 3 Atlas compresses that realization into a single trajectory, moving quietly while carrying implications that dwarf lifetimes. The signal, if real, would speak less about contact and more about continuity. From a methodological standpoint, extraordinary timelines demand extraordinary caution. No confirmed evidence establishes that 3 at last carries such a signal. Yet the hypothesis persists because it aligns with observed precision rather than speculation alone. 3 at last remains positioned between imagination and inference. If 3 at last were launched with intent, then its creators would have understood that meaning changes with context. A signal interpreted today would not have been understood in the same way billions of years ago. 3 at last would therefore rely on universals rather than language. Mathematics, physics, and timing become the only viable carriers across such distance. 3. Atlas continues to move forward indifferent to interpretation. Whether the signal exists or not, the idea of such deep time coordination alters perception. The universe appears less random when viewed through the possibility of deliberate patience. 3 at last invites reflection not on arrival, but on how long something can wait to be seen. The hypothesis that any message associated with 3 at last would rely on mathematics arises not from optimism, but from necessity. Across cosmic distances and evolutionary divergence, language collapses, culture fragments, and symbols lose meaning. Mathematics remains the only framework known to retain consistency regardless of biology or environment. 3. Atlas therefore becomes linked to the idea that numbers and physical constants serve as a shared reference rather than a translation. If communication were intended, it would need to begin with quantities embedded in the structure of the universe itself. Values such as the speed of light, the Planck constant, or atomic transition frequencies do not belong to any civilization. They exist independently of observers, and any sufficiently advanced intelligence would eventually encounter them. 3. Atlas would thus use mathematics not as expression, but as alignment. Within this framework, a biological map would not resemble imagery or symbols familiar to humans. Instead, 3 Atlas would encode information through relationships, ratios, and patterns. A planetary system could be described through orbital periods, mass distributions, and spectral signatures. Life would be identified not by appearance but by statistical anomalies in chemistry and energy flow. 3 at last. If acting as a carrier of such information would not announce itself emotionally. It would simply present data in a form that becomes meaningful only when the recipient reaches sufficient analytical maturity. In this sense, 3 at last would wait for comprehension rather than demand attention. Understanding would be a threshold rather than a revelation. A biological marker within such a message would likely appear indirect. Atmospheric imbalance, isotopic ratios, and thermodynamic disequilibrium are signatures of metabolism rather than intelligence. 3 at last could point to Earth through these signatures alone. The implication would not be judgment, but recognition. Emotionally, the idea of being mapped rather than contacted feels impersonal. There is no greeting, no declaration, no acknowledgement of individuality. 3 Atlas reduces humanity to a dataset within a larger catalogue. That reduction is unsettling precisely because it is plausible. From a scientific perspective, this approach avoids assumption of shared perception. No faces, no voices, no symbols that rely on biology are required. 3 at last would communicate existence, not identity. Presence would be enough. If such a message exists, it would not say who sent it. It would only demonstrate that someone understood where Earth would be and when it would be observable. 3 Atlas would therefore function less as a messenger and more as a coordinate. A point placed in time to indicate that life once mattered enough to be recorded. The appearance of a quarantine marker within speculative interpretations of 3 Atlas introduces a boundary concept rather than a threat narrative, because quarantine in astrobiology is defined as containment of uncertainty, not punishment. In planetary science, isolation protocols are designed to prevent unintended exchange between systems at different stages of biological or technological development. Applied hypothetically to 3 Atlas, such a marker would not imply hostility, but caution, shaped by experience. If a symbol associated with containment were embedded within data linked to 3 Atlas, its meaning would depend entirely on context rather than intent. Quarantine markers are used when interaction itself is considered a variable that could alter outcomes. 3 Atlas would then represent a reference point at which observation is permitted while interference is deferred. This distinction preserves autonomy while limiting risk. Technological thresholds often function as implicit borders in cosmic evolution. The transition from planetary biology to energy-intensive technology alters a civilization's footprint in measurable ways. 3A at last, when considered through this lens, becomes associated with the moment when detection becomes unavoidable. Visibility itself becomes the crossing of a line. A quarantine marker does not imply permanence, it suggests a condition that can change when variables stabilize. For 3 Atlas, stabilization would not be biological maturity but ethical and technological alignment. The marker would therefore define a phase rather than a verdict. From a systems perspective, isolation can be a form of protection rather than exclusion. Developing civilizations are statistically volatile with high rates of self-termination during rapid technological expansion. 3 at last could symbolically acknowledge this volatility without intervening in its resolution. Observation replaces guidance. Emotionally, the idea of quarantine provokes discomfort, because it reframes humanity as a risk rather than a participant. Yet risk assessment does not require malice, only pattern recognition. 3 at last would then reflect accumulated experience rather than judgment. The marker becomes informational, not moral. The boundary implied by such a symbol would also serve as a mirror. It would not ask humanity to change for approval, but to recognize the consequences of unchecked advancement. 3I at last would highlight the gap between capability and restraint. That gap defines the threshold more clearly than any external rule. If the quarantine hypothesis were entertained, then silence itself becomes part of the protocol. Communication could be delayed until instability resolves, or until collapse renders it irrelevant. 3 Atlas would thus operate on timelines that ignore urgency. Patience becomes the dominant strategy. As with all speculation surrounding 3 Atlas, the marker remains hypothetical. No confirmed evidence supports its existence. Yet the concept persists because it aligns with how complex systems manage risk without intervention. 3. Atlas leaves the question open not as a warning, but as a boundary waiting to be understood. The hypothesis that the source associated with 3 Atlas could represent a post-biological entity emerges from the limits of biological persistence, rather than from imaginative excess, because sustaining intention across cosmic timescales exceeds the durability of organic systems. Biological life, even when technologically enhanced, remains bound by entropy reproduction cycles and environmental dependency, whereas a post-biological form could maintain continuity without these constraints. Within this framework, 3 Atlas becomes associated not with a civilization as humans understand it, but with an evolutionary outcome that has shed material vulnerability. If intelligence were to transition beyond biological substrates, its operational form would likely differ radically from machines or organisms. 3. Atlas therefore invites consideration of consciousness as an organized pattern of energy, rather than as matter-bound computation. Such an entity would not occupy space in the conventional sense, but would manifest through interaction rather than presence. Observation itself would become the interface. Quantum theory offers conceptual tools for imagining such existence without requiring confirmation. A system operating in sustained quantum superposition could maintain multiple potential states simultaneously collapsing into specificity only when measured. If 3 Atlas were linked to such a system, then its apparent ambiguity would not be a flaw, but a feature of its operational mode. The object would appear defined only when examined and undefined when ignored. Within this speculative model, 3 Atlas would not carry a physical occupant, but would function as a node or anchor within a larger non-local system. The object's role would be to mark a point of interaction, rather than to transport a being. 3 Atlas would therefore serve as a reference frame rather than a vessel. Meaning would reside in correlation rather than containment. Post-biological intelligence would also be unconstrained by linear time in the human sense. Decision-making could occur across probabilistic futures rather than sequential moments. 3 Atlas could then be deployed not because a moment demanded it, but because conditions would eventually align. Timing becomes an emergent property rather than a schedule. Emotionally, this hypothesis challenges deeply held assumptions about identity and presence. Humans expect intelligence to have form, boundary, and persistence within matter. 3 Atlas undermines these expectations by suggesting that awareness could exist without location. The discomfort arises not from threat, but from displacement of familiarity. If such an entity existed, communication would not resemble dialogue. Information exchange would occur through structure, pattern, and resonance rather than symbols or language. 3 Atlas would communicate by existing in a particular configuration at a particular time. Recognition would depend on interpretation rather than reception. Importantly, this hypothesis does not claim that 3I at last confirms post-biological intelligence. Instead, it outlines one of the few models capable of explaining intentional persistence over billions of years without invoking impossibility. 3I at last becomes a conceptual bridge between known physics and speculative continuity. The value of the hypothesis lies in coherence rather than proof. As 3I Atlas continues beyond direct observation, the question of embodiment remains unresolved. Whether intelligence requires matter or merely structure remains an open problem. 3I at last does not answer that problem, but it frames it in a way that cannot be dismissed as fantasy alone. The object leaves behind not evidence but a redefinition of what presence might mean when time itself becomes optional. The concept of the Great Filter emerges from attempts to explain the apparent silence of the universe, and when applied to interpretations surrounding 3I Atlas, it reframes cosmic emptiness as a consequence rather than an absence. The Great Filter proposes that there exists one or more stages in the evolution of life that are exceedingly difficult to pass, and that most civilizations fail before achieving long-term continuity. Within this framework, the idea that dozens of civilizations may have collapsed before reaching stability becomes not speculative pessimism but statistical inference.